And good morning, everyone. Thank you for coming to my session. My name is Brian Randell, and this is 8 years of CPU in a day. Come to Valhalla with Azure DevOps. So, info about me, email address, Twitter handle, which is the best way to get a hold of me, and my blog, which I occasionally write at. Let's get right to it since we have 45 minutes. So, real simple. How do you get 1,500 VMs running in one cloud in one day? So back in June of this year, Xspirit with Solidify hosted the first global DevOps bootcamp. And the goal was simple. They wanted to expose people to all the great tools that Microsoft has to help you build great solutions on Docker containers on Windows using Visual Studio Team Services and Visual Studio. And so they wanted people to have a hands-on experience. If you do any development, you know fundamentally getting your development workstation correct to get a block of code to compile and deploy and do it all in one environment can be difficult. In particular, we're trying to give them an environment that has it all, right? It's one thing if maybe you can separate and have a separate machine that's running your containers, for example. But they wanted everybody to be able to do that. And they wanted to do it at a scale that anyone who could get to an office where it was running could try things out. And so we've been working on our product, and it was funny because I ran into Marcel DeVries from Xspirit at DockerCon. And at DockerCon, we ran 3,200 VMs over 3 days using a combination of both Windows VMs and Linux VMs. The key thing about this is when you start going to scale, it gets more complicated. And so we did for the boot camp, which we've done for Docker, which we can do for small groups as well as large scale. So what is Duo Myth Valhalla? It is the product name. Now, marketing people tell me it's not a good name. I'm a geek. I was watching the movie Thor, and we needed to call it something, so that's where the name comes from. It doesn't have any deep meaning other than it's what we kept. That said, I'm sure we'll get a marketing person who'll make us change it. If it's a Microsoft thing, it'll be the Super VM Management System 2016 for Microsoft Azure Cloud, But in either case, it's a purpose-built platform that are focused on helping people learn and learn in a hands-on experience. So while our initial people that have used it are probably developer-focused, it's designed for anyone that has to work with software and go through that experience. You run into organizations, for example, that have been on an older version of Microsoft Office, say Office 2000, Office 2003. And then they finally do a big upgrade, right? One of the big pushes we had was getting people off Windows XP and onto, say, Windows 7. We're going to see a similar push where Microsoft's going to move them forward. And one of the things we can do in this environment is spin up these VMs, provide them with a new environment that mimics their work environment without causing problems, and they can train. Complex software solutions where you want to have people try your software, but to do a POC engagement on-site in their network environment increases the cost and time. The ability we have is to generate whether it be a single VM or an entire virtual domain that we can replicate across the world and allow you to use it. We first started going into production in early 2014, and today we've managed over 15,000 VM instances. Now, the bigger answer, though, and why you're here, is to learn a little bit of the why and what matters to you if you're using Azure. I mean, you can create a VM in the Azure portal, right? Everybody knows how to do that. Okay? Who wants to create 1,500 VMs with the portal? Anybody? No. Now, of course, there is PowerShell and ARM, right? Anybody know PowerShell? Okay? So, quickly, let's go back to this picture right there. I want you to write me a PowerShell script that can handle deploying over multiple time zones in multiple data centers, multiple VM types, and I want you to use non-generalized images. Do you get where I'm going with this? It turns out at scale, you can do it with PowerShell, because just like in the days when I programmed VB, right, VB-conv, I could do anything with VB, because Dan implemented and people said I could. And then I realized there were times when I went to hire a C++ programmer. There's times when you want to apply the right tool to the job. And I'm not saying that there aren't PowerShell wizards that could do this, but it can get painful. So, going back here. the biggest thing to consider at the root, the complexity about what we're doing with Valhalla and what you have to consider if you're building on top of Azure is that you are one of many. You are a tenant in a multi-tenant environment. This means that Microsoft has to guarantee that the experience is good for me, but it's good for this gentleman, and for those gentlemen, for all of you, right? It has to ensure that if we're all paying money, that we are treated fairly and equally under the law, right? The law of the cloud. And so if you're going to do that, that means things that you model in your head, that you design and architect, don't always work the way you think they are once you get into that multi-tenant environment. And ultimately, there's no place like production, right? Since 2014, we have deployed these small installations, labs, 10, 20 users, to these large-scale events like DockerCon, where we're actually allocating even more than what we're showing on the numbers there. Because there's a little, I don't want to call it a dirty secret, but the SLAs and the guarantees Microsoft provides are very specific to what you're doing. And it turns out using VMs for labs and individual logins don't have the same SLA as VMs you might use to host a load-balanced web farm where each image can effectively be the same. Right? There's no way to do failover of an RDP session if someone's logged in interactively. If the VM dies, the VM dies. Or if the VM's not available, you can't just hand them off. So it's those type of things. So here's some things to consider, right? And this, after you get through this slide, this is the core thing. If you want to stay for the rest, it's great. But these are the secrets and the things I'm going to tell you about that you need to know. When we built Valhalla, one of the key things was to go beyond the management experience that you get with the Microsoft tooling, whether it's through PowerShell directly or through the portal. Right? Today, the console aspect of managing your solutions in Azure is bound in a combination of your directory, your subscription, and then the region in which you've deployed your resources. All those things have to be taken into account when you want to do something. Which means when you think about, I want to spin up 1,500 VMs across the world on a sliding schedule, you're not going to be able to do that in a single subscription, in a single time zone, a single data center, and provide a great experience. You're going to have to fan out. And the Azure portal doesn't provide a great experience for that. It's not optimized for that. So when you start thinking about how you're going to represent your data center, right? Azure's now your virtual data center across the globe. You start thinking about how do I do this from a custom perspective. And so that's one of the things that we had to do with Valhalla. If you want to get scale, you're going to have to start thinking multiple subscriptions, and those multiple subscriptions will then also give you access appropriately to multiple regions. There's a standard set of regions that are available to a regular Azure subscription. In other words, one I can go to right now in Azure and sign up with my credit card. Then there are specialized regions that you only get access to through appropriate contracts or where you live. Anybody from Germany? No Germans, okay. Anybody from the UK? Okay. So, turns out the UK currently is still very friendly to us. I can actually run stuff in the UK cloud, no problem. I cannot, though, just go run it in the German cloud, which is run in partnership with Deutsche Telekom. Okay? You have to have a business license and whatever, there's rules about it, in Germany. You have to have a business presence. And obviously the Germans are very good at the structure and rules. There's there. Working in China is the same thing. You can't just provision resources. In addition, Microsoft supports a number of what are loosely referred to as government clouds. They have a formal name. But the government clouds, of course, are only available to the governments which they support. So in the United States, for example, there's a government cloud that is for generic services, and then they even have more specialized ones for things like the Department of Defense. So you have to understand where things are running. And there is this benefit in certain services to being closer to the people you're working with. The other thing that you have to understand is that subscriptions have tenant limits. The limit, for example, with virtual machines is you're limited to a hard number of cores. 10,000 is the maximum number of cores that you can get in a single subscription. Well, you start doing the math, and you're saying, okay, well, that's not a big deal. And then you go, wait a minute, well, I want quad-core machines, or I want octa-core machines. You start doing the math, and all of a sudden it's not that many VMs, right? Thanks to some optimizations and what they've done with the VM types that are available, the hardware it's running on, and the fact that now we have the ability to have SSDs, we were able to run most of the VMs for the Global Bootcamp, for example, on just dual-core VMs, right? In particular, when someone's sitting there doing interactive, you don't need that many cores because there's a lot of think time, okay? But when you start doing the math, you start realizing, I'm going to have what I need to do for actual production, and then when we run events for people, obviously it's up to the customer because you're paying for this, we run a certain percentage of backup images in an alternate location. So to give you an example, at DockerCon, we ran 3,200 VMs out of the South Central Data Center, which is near San Antonio, Texas, right? We were in Austin, Texas, so that was the closest physical locality. So to give us really nice low latency access both through RDP and SSH. Could we have got away with being further away? Absolutely. But once again, this is to provide a premium customer experience. However, what happens if something happens, right? The data center goes down or something happens with our VMs. Well, to protect that, we also allocated 50% of our capacity that we needed in the North Central Data Center. And that was in case of VM went down. Now, here's the great thing. In the last year and a half, 2 years, we have not had to use any of the failover VMs. We've either had enough capacity in our set, occasionally 1 or 2 VMs, doesn't come up, whatever, you give people a new one. Or, most likely happens when people do labs with their developers, they hose the VM. Developers are very creative, especially the Linux developers. So at DockerCon, we often had to give them another set of VMs, but that was not Azure's fault, okay? So you have to understand that you have subscription limits, which is resources, but there's also one here. You can only go so fast, all right? So imagine you're wealthy and you have a large estate, and from the road to your house, you've decided to take the long way. In other words, you've designed the road to mimic a nice road course, right, with a few chicanes, a few hills, a little fun stuff, right? And so you pull off the road and get in your mind your favorite sports car if you're a rivet head like me and like Top Gear, right? I drive Bavarian, so I have a E60 M5 V10. So, okay, you're coming in, you have the distance, you have the range, you can go fast. It's your environment, right? It's your private playground. Now, let's take this though to maybe it's like a parking lot here at the Rye. Am I going to really get to enjoy my vehicle in this parking lot? Not without risk, right? If I go too fast, what can happen? Pain and suffering, right, at the end of the day. Well, guess what happens in Azure? Azure is going to say, look, you can only go so fast. It turns out if you start doing things too fast through the system, they put a limiter on. There's actually a resource governor. And for various reasons, they don't document and say, if you do this many things, it happens. So I can tell you from experience, one of the things we don't do is say, give me 500 VMs in a single resource group. It turns out you start running out of resources. There's another thing. When you define your subscription, Microsoft says, so, sir, what's your name? Pedro? Yeah. So, Pedro, how much money do you have? So if I go and get my subscription and I let's pull out my debit card, they laugh at me. Ha, 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 that's not enough money. And I go, Amex? And they go, okay, you can have a little more. You want a lot of resources, they're going to tell you, let's sign a more formal agreement, okay? Let's make sure you can pay. So first, when you create a subscription, the amount of resources you have access to is a lot less, right? The cloud is elastic, but your bank account may not be. So what happens is you have to make sure that you have requested the number of resources you want, where you want them. So there's a whole plan, a resource plan that goes into this, all right? Now once you've got it, though, you say, hey, I can pay for those 10,000 cores. Great. When you go to Azure and say, give them to me, if you don't plan, guess what? They're not available. It turns out that while the cloud is elastic and Azure has an enormous amount of resources, you can't just necessarily be a pig and take them all. So when we ran events, we had to go and say, I would like this many type allocated to my subscription. We had the ability to pay, because thankfully Uncle Scott's paying for it, Scott Guthrie, because Microsoft sponsored that. That was very nice of them. And what happens is we had to go and justify what we're doing. What are you guys doing? How long is it going to be? What's going on? Because they have commitments to other customers. They have to be able to allocate those and make sure they're treating those customers fairly. We did work with a large actuarial company in the UK. When they go through their production runs, they will consume hundreds of thousands of cores in Azure. But they do it for a short period of time. Now, Microsoft loves it because they make some nice coin off that, right? At the same time, the customer can't just go, give us 100,000 now. They have to be prepared for that and have it designed well, okay? The second issue you run into is data persistence. Microsoft keeps, first of all, improving this. Where we started 2013, I'm so glad we're not on. In other words, the way we did it then is not the way you do it today. The way I would do it next year is going to be different. So a couple things you have to worry about when managing VMs, which is where you start to break down with PowerShell, which is, number one, managing clone management. So when you go in to do a lab, right, someone has to create the core content. You have to install Visual Studio, get it configured, etc. And as I said, you have two types of images you can have. Basically, generalized images. In the Windows world, that means sys-prepping them. Or what Azure refers to, the non-generalized ones, are just attachable images. In other words, you can attach them to a VM and use them. If you use generalized images, it turns out that Azure, through the ARM template, will do the copying for you. If you point to the source, it can take care of the copying for you into storage and doing the duplication. If, on the other hand, they're attachable VHDs, you have to do that yourself. Now, here's another thing. Microsoft introduced SSDs. Totally changes the experience when you're doing interactive work, but they cost a lot more, right? For a single instance VM, you're going to pay roughly $15 a month US for a single VHD. 1,500 VHDs. Oh, that can get expensive really quick. So you only want to allocate the VMs at the last possible moment. So we do extra work when you actually ask for things. We allocate the resources in the plan, but we don't actually allocate till it's time, right? Till you actually say go generate it. So lazy initialization saves money. That makes the customer happy. Now, another issue that gets more complex than just starting out is it's fine if you go through and you allocate and say, give me 50 VMs, and it just happens. Life's good. Now what happens is that you have some DOA VMs. Let's say someone's messing them up, and you end up with a hole of 3 VMs. How do you fill those holes, right? This is why having a system, whether it be something we wrote or someone else writes, really takes you to the next level in managing at scale. Because what we want to do is, remember, allocated a certain number of resources that we can use in a data center in a region. Well, if I've got empty resources and I have demand for them, I'm going to want to reuse them. So figuring that out manually and then going and deleting the portal and then updating your PowerShell script to do that is where things are going to go horribly wrong. So having some kind of system that tracks those, which is what ours does, persistence, the ability to refigure it out. Here's another one, load balancing of ports. So it turns out you're limited in your IP addresses. Go check your subscription. Microsoft only gives you a certain number of public IP addresses. Well, what if you want to run something at scale like we do? Well, we support using the load balancer to surface multiple VMs, and I think Ian said the limit's about 150 VMs behind a single IP. And so if we're doing RDP or SSH, we can map a custom inbound port to the standard ports on all the VMs. Now, what happens there if you have a sequence, right? RDP starts at 3389, right? So you start at 3389 and start going up. Let's say you're at 4020, and that VM's dead, but you got 4021. You're going to want to reuse that port if you have to reuse the VM. So again, that's where logic and processing, and what I'm sure a lot of you do as programmers can do, that's not going to be as simple as PowerShell, and of course no one's going to want to do that through the portal. Retry handling, DOA, VM detection. So first of all, Azure's really good, but here's something I'll warn you about. Let's say you want to go ask for 50 VMs. Once you give the control to Azure, it will go and do it. Now you can monitor things through the portal, and you can see what's going on. However, here's one of the problems. Azure doesn't return control until it's done. Well, it's possible. We've had this happen. You're going out, and there's a DOA VM where Azure figures out it's dead, and so starts retrying, and then eventually comes back online. So the problem is you're doing this constant game of are we done yet? Are we done yet? Are we done yet? And then also knowing that there's sometimes that Azure doesn't know it's done. In other words, or doesn't know it's dead. So we wrote, in the case of the Windows VMs, we haven't done one yet for Linux, but a custom Windows daemon that is able to communicate with Valhalla once it's alive to say, yes, I'm really there. So we can actually correlate the data from both Azure and ourselves to find dead VMs and not hand them out to students. And then what we do is we can say, hey, we've got 48 out of 50. Let's go give those out, and then we'll reset the 2 that are dead ourselves, and then we can hand those out later. Okay? And ultimately, access management. You're not going to get this out of PowerShell. When we want to give you a VM, if I want to give Pedro his VM, I'm going to get his email address, his name. He's going to get a nice email that's going to have his links, his customized security credentials, all to get to the VM. Because, no offense, but I'm not going to let you into the Azure portal to connect. Right? So those are things you have to do. And then even self-service access. Right, at DockerCon, we ran things a few hours. Mickey and I were there with a couple other people handing out VMs and letting them use it, and it was during the event. But what if you're running a class all week and you want people to work on homework, right? Well, you want to give them self-service access so we can monitor timing, those type of things. So in summary, when you think about working with Azure, don't assume because it looks good on paper it's going to work. The root issue is you're living in a multi-tenant environment, and that multi-tenant environment is only going to be as nice as how much you can pay for, as well as how you respect the multi-tenancy, right? So you're kind of like, you know, how good is your apartment? How good is your condominium, right? How good is your hotel room, right? You can pay to a certain degree to get more services, and yes, you can go faster at certain degrees, but at a certain point, they're only going to allow you to run down the hall as fast as possible. And so what you end up doing is saying, we need more than one hotel suite, right? We need more room. Now, from a development standpoint, we do DevOps when it's no ops, right? It's Ian and I. We're both primarily developers. Ian's the chief boffin, and so what I tend to do is I do everything else as necessary. We started in 2013, and then we started working with, at the time it was VSO, and then Team Services. And fundamentally, doing a startup today is a whole new world compared to was when I worked in the 90s. Having to not buy hardware, not have to have commitments, to have access to modern technology for automation, it's absolutely wonderful and amazing. DevOps, by law, I have to show you this slide, right? But basically the key is it starts with people, and that's one of the success points. Ian and I work together. We don't do all things traditionally how you might do it in a dev shop. We don't do a lot of pull requests, right? We tend to do daily meetings together and go over the code changes, work together, things like that. So there's kind of understanding how we can operate. The minute we add a third person or a fourth person, we're going to have to adjust our process, right? And we're constantly looking at how tools can help us deliver value. Now, real quick, I just wanted to show you our real environment in VSTS. So this is our old one, and there's just some legal issues as to why we were here. This is my consulting account, and you'll see we use the dashboards. We're able to do our deployments. You see we're using builds. Basically, VSTS does everything for us. So we were able to basically take our changes, push them up into our Git repository, which you can see here. We had multiple repositories based upon major versions of the product. So Finsbury was our last classic version of VSTS that we supported in production. And when I say classic, the first generation of Azure. So when you created a VM, it would run as with a cloud service, which would give you your IP address to give you your networking access. Totally different now under the ARM world. We use the backlogs and everything to track our work, and we use builds and releases to handle the automation. Test is definitely a major aspect. We'll talk about that more. And then now we've moved on. This is the new dashboard. And this one right now I'm working out of. You can see I've done some commits the last couple of days. I'm starting to work on the user experience. So in the previous version, we had a full, I don't want to say nice looking because I respect UX work, but the bottom line is the artists and designers had done some work to make it look nice. Right now, the UI, as you'll see when I show it to you, is very Spartan. It definitely has a developer a coat of paint on it. But in either case, you can see I can make changes here. These get then translated to builds. We're firm believers in CI, CD, and unit testing. So you'll see we have two builds here. The first one is called Valhalla CI, and this build is responsible for going through, doing the builds, as well as running the unit tests. Right, you want the test to run as fast as possible, and Ian, it looks like, has been in here making some tweaks. We made the choice to start using .NET Core, as well as ASP.NET Core at a certain point, so we've got a mix of that. As you'll see, then we have some of the Visual Studio projects. And yes, we're even using some Node.js in the solution. One of the key things is that we do run the unit tests when you run the build, and we're using the triggers feature, which allows us to execute the builds anytime someone pushes into master, as well as any of our feature branches. So automatically it picks up any custom feature branches, and we're checking those before we integrate with master. And if we go back up here, let's just go to the builds. And if I go to the last run build for this one, and look at the build report, you can see some fun stuff with changes. We get great traceability, and right, this is one of the, whoops. Let me run zoom it. Windows key, sorry. I was going to show you. One of my favorite things about this is you can see what caused this build to occur and what was the person doing. So I'm the one who kicked off the build. I'm the one who did the change and why. So I get this traceability, which now is in my build. And then what we'll see is that if we go back up to our builds, we have a second build. Now, the distinction is this. We need a number of packages to do our automated deployment. Generating those packages doesn't necessarily give me the value as a developer if something's wrong and I want to find out as soon as possible, because it takes longer to run that build. So the first build that kicks off is the CI build, which is your smoke test. If that passes, then you're like, okay, while the other one's working, I can continue to look at what I'm going to do. If it breaks, you stop right there and go. The second build builds all the packages used by release management. And as you can see right there, it ran this build, and you'll notice that it's got the -UXWorks. So we've customized the build name to tell us what this build, what branch this came from. And then you'll notice right here, you can see that I've done a deployment. And we have a number of different deployments here. Most notably, WSDev01, which stands for West US, is the region. This is my dev environment that I have fully deployed in Azure for me to do dev and test. And then finally, we use release management to do the release. And if we take a look at that, you can see that I did the deployment there. And you'll notice I get the traceability here. So this really helps us with our MTTR and MTTD, right? If something goes wrong with a deployment, I go straight to release. I should see generally one or two tasks, right? We try and do we try and be very active about pushing and sharing code. I can go there, look at the code. Oh, that's where the mess up, and then I can fix it, and we can roll forward very quickly. So this is where having something like VSTS, which, by the way, for two of us, this is free. The only thing we pay for is we run a private build agent and release agent, so it runs faster. We have it running in Azure on VMs, on an Azure SSD VM. And so we spend probably about $70, $80 a month for the VM. I forget what the cost is. But otherwise, everything else we get out of the VSTS, we're getting for free. Well, nobody writes for free, but you get the idea. Right? I don't have to write at Microsoft a check specifically for this. Now, let me go back here. Now, this is basically the architecture, and you guys can look at this later. You also, if you want, you may have gotten a Spirit magazine in your bag, etc. We wrote a little article that talks about some of the stuff I'm doing here and has the diagram as well and talks about what we did. But in either case, at the end of the day, we've moved to a secured by AD implementation. So our first implementation, we had a roll your own security. You don't want to do your own, right? It's much easier to use Azure AD. We use that for the core management. We use our org IDs, and then we can give access to external users to the B2C connector as well as through their MSAs. We have a web user interface. Another big change we made from version 1 to 2 was table storage versus SQL database. When we first started, we looked at table storage as a more cost-effective way to do things. The problem was we paid for it in development and debugging time, right? I'm old. I grew up programming relational databases, and even Ian's done a lot of that. So it made sense to spend a little more on our runtime cost to reduce some of the complexity in our code base. So that's made a huge difference in diagnosing errors, and I'll talk about another feature we use there. Today, most of our worker process has moved from worker roles in Azure Classic, web jobs, fantastic technology. And I'll show you, I'm going to dig into that in a second. We also take advantage of the Redis service. We use application insights to monitor things. And then the other thing that changed in moving from a more imperative programming model that we had in version 1 on Classic, where we use PowerShell and a lot of C# code, is that we've taken a bunch of code that was ours, and Microsoft takes care of it, because we're using the declarative model of ARM resource templates. So basically what an ARM template is you describe what you want Azure to create for you, the VMs, the resources, etc. And you hand it off there, but you have to interact with it and manage it. We also support talking to other APIs. For example, one of the things we can do when spinning up VMs, I can also spin up a Visual Studio Team Services account. I can load it with work items, sample data, etc. And we can talk to other Azure services. And at that point, it can run. Now, our solution runs as a multi-tenant service that we can run for you completely and do it all. So literally, you just pay for everything, and we charge you back both the Azure cost and our cost. Or some of you work at companies that you guys get a better deal from Microsoft on your Azure costs, right? Or when we do work for Microsoft. Microsoft's not going to pay us to run stuff on Azure for them, right? They're not going to pay for the Azure cost. So we run the system in their subscription, 100%. And we can also do a hybrid one where we run the management portion, so that box over there, the Valhalla box, yet all the code and VMs run in your subscription, right? So once again, that's another thing that you start realizing that at the end of the day, if you're building any PaaS solution on Azure, get a grip on directories. Understand how AAD works. Understand how data centers are made available to you through regions, and immediately understand you're going to want to have more than one sub and possibly even more than one directory to really give you that flexibility and that scale out. Now, what happens when you want to spin up a bunch of virtual machines? So before I show you what's going on, I'm going to go to our website, and once again, don't hate us because we're not beautiful. Let's see, it's in that one. There we go. So this page right here shows that I have a bundle called TechDays Server. So this is just a very simple bundle that has one VM. Like I said, we support entire domains. One of the largest ones we did was for the sales folks in the US. They were trying to get people to use TFS, and we did 15 VMs in one bundle. So I could give each of you your own private domain with 15 VMs with an entire Exchange server, SharePoint, etc. Thankfully, we don't do as much of that because I hate installing Exchange in SharePoint. But in either case, this is very simple. And then you'll notice we have what's called a provision-ready environment. Very simple that a provision-ready environment is just our name for a set of VMs that you want available in some place. I've scoped this to the West Europe data center, so all I have to do is click Create New Provision-Ready Environment. I give it a name. We'll call it Live Demo NL, and click. Now, what that did was that said, okay, we're going to define some data inside SQL Server about what you want. And now we want a number of VMs. How many VMs do we want? Well, I would tell you, give me a crazy number. The problem is, I'd like to have something left, so we'll go with 7, because I feel lucky. And I'm going to click Add and Leave Running. So while that's doing, you'll see right up there, Provision Requested Queued. And we're going to come back up here, and I'll show you Azure in a second. But what's happening? When I click that button, we've gone through and read information about all the things you want done from SQL Server. So we've modeled our domain in SQL Server tables. We then load that information up and construct what we call a plan. We then go through and transform a core section of that plan into a JSON document, an ARM template. We then take that ARM template and we deploy it to Azure through what we call Tenacity. And Tenacity is our workflow engine. If I started coding today, I might look at replacing some of this, if I hadn't written it, with some of the stuff that's in Service Fabric, right? Microsoft has really started making some of their stuff really cool. Wasn't available when we wrote the first version, and wasn't Wasn't something we had a lot of faith in when it was available in pre-release. That's the other thing is, we live on the bleeding edge. And that ends up handing things off to Azure. Now, I wanted to show you the code real quick. And so, since this was supposed to be 400 level, I thought the appropriate way to show you this was with ILDASM. Whoops. I got the name wrong. There it is, Valhalla Worker. All right, so let's go in here. Okay, I'm kidding, right? It just seems like if it's 400, you have to show ILDASM, right? I'm kidding. And I do have the source code. Oh, yeah, just show me there. So that's just a Visual Studio. Now, while Visual Studio loads a solution, I didn't realize it had done this. Let's come over here. Let's refresh the list here, and then let's look at PRE. And what we'll see here is, does anybody remember what I called it? It was live demo. So there's my resource group. It's already been allocated. And if we go look at the resource group, no, it's been busy already. So you'll notice what we've done. We've gone out here to find the network interface has already been set up, the public IP addresses. I've set up a VNet for the virtual network. That's another thing we can do is isolate the VMs from each other, which was really important doing the DockerCon labs with the folks doing Linux because they were doing clustering. And you'll see it's allocated the virtual machines. You can come over and watch the deployments. Unfortunately, Azure lies to you a little in that it'll often tell you things are done here when they're not completely done to where you can actually use them and allocate them. So one of the things we do is go back to the other browser, and you'll see it's creating VMs. All right, so hopefully someone's timing it, but basically what you'll find is, effectively, it should take us about the same time to create one VM if you did in the portal to create all 7, right? Now, like I said, as you start to increase, you start getting above 20, 30 VMs, there is a chance that you'll run into something that hiccups a little, okay? And what will happen is that slows down your entire overall run. That said, our telemetry over the last couple of years, Microsoft keeps making Azure much better. I will tell you there was a period of time when I wondered about doing this business in the summer of 2014. The A-series machines were crap, right? But that's why Mark Rasanovich went out and they said, we're going to get better hardware. They introduced the D-series. And now, recently, they've introduced the B-series, which we think are going to be really great because of the burst mode, which would be perfect for people doing labs where there's a lot of sitting there thinking, doing stuff. Oh, okay, now I want to do a compile. Sit there, think. Oh, I want to do a deploy, right? And that's really a great thing. That's a cost savings. So as I said, what we've done here, no, I don't want that added. So that is just some HTML, which you don't care about. Ah, here we go. So first of all, we use our database is modeled using SSDT. And what you're going to see here is these tables here represent all the different pieces that ultimately represents an environment that you could use, right? So we have to define which source are the VHDs. What region do you want to run in? Do you want to run in West Europe? In the case, obviously, of Global DevOps Bootcamp, we ran out of the Australian East Data Center. We ran out of multiple data centers in India. We ran out of the West Data Center here in Amsterdam. We ran out of the South UK Data Center. I would have loved to be able to run out of Germany since we had a bunch of people there, but I couldn't convince Deutsche Telekom that I had a German address. And then we ran out of the Eastern Data Center in the US, the South Central, the West, as well as we ran out of the Brazilian Data Center. So we basically describe all that information in a set of tables, and then Ian, when he wrote the second generation, wrote some F#. Anybody do F#? It's pretty amazing. It worked out really good. Being able to model the data. So basically we go through this stage where we model the resources, in the case of the plan builder, figure out all the different data sources that we're going to use. Then we come over here, and ultimately what you care about is how does this actually get shoved into Azure? Well, we come down here, and we have this deployer that then goes in, I think it's up around 695. There's a call, yeah, right here. That's for passwords, a little further up. Make VM. So this goes through and basically reads the data of the database, starts and forms the JSON document, and then ultimately we feed this into Azure. write down. You know, I had a bookmark. Where's my bookmark toolbar? Next bookmark. There we go. That is actually the line of code. So that line of code there is actually taking all the data that we've now transferred from our domain model into an Azure ARM definition, and then we throw that to Azure based upon how many we're running at. And we go through, and then while it's running, we can actually fan out and do it across multiple regions, multiple data centers at the same time. Now, basically, we should be done here, yes. So I've got 7 VMs ready to go. Anybody want a VM? Anybody? Everybody gets a VM. No. And then the nice thing about this is you can also, anybody have to go in and shut down the VMs and then deallocate them? Well, let's just do that with one button. So really quick, we'll prove that they're there. So we'll come over here. Let's see, refresh. Yep, we got all green lights from Azure. There's all our VMs. Okay, so let's just pick one really quick. And sure enough, if I wanted to, I could connect. Problem is, I don't know my password. Turns out the system, I can go and assign that, but at this point, you get the rough idea. Hit deprovision, and there we go. Got to put some safety rails there. Ian just said, "Oh, screw it. You click the button, you meant it. It's done." It's actually taking down all the VMs right now, so that's pretty good. Now, demoed that. So, summarize some lessons learned. Number one, testing is a key to success. We run about 700 unit tests right now on the builds. Inside Visual Studio, we have another 1,400. Why the difference? It's real simple. .NET Core and the tooling has gone through some moments of pain, and so we haven't had a chance to sit down and figure out now with the latest RTM tooling, figure out what the problem is between the build and there. So Ian's pretty religious about running them. We run them in both places. But the other thing, automated integration tests. This is one of my favorite pictures from the internet. Hey, the unit test pass, but the integration test. This has been critical to making our lives sane. We also do manual tests. For the automated tests, we run those out of a systems test release that you'll find over here. Come back over and we go to release management, system tests. And, whoops, that's the wrong one. Let's go over here. And, oh, it looks like the last test has got problems. But basically what happens here is we have done a combination. We did some automated tests with Selenium in the previous version. Biggest problem with using automated UI execution tests is that when your UI changes, they break your tests. And so we're right now between UIs. As I showed you, our UI is kind of ugly right now. So for now, what we've done is Ian wrote some custom PowerShell and some C# that will actually talk to Valhalla and have it generate a new deployment of Valhalla. So we redeploy all of our foundation services from scratch, and then we go and allocate VMs, check the results. And so this runs a full end-to-end test suite. Depending upon how large the test is, it might take 45 minutes to an hour. But that replaces what was taking hours of mostly me, him shouting at me to go through and try things and going through my scripts manually. So we still do this occasionally, particularly when we've done something significant. But once again, this is the only way to survive in the modern era. Moving to the latest Azure features has a cost. Well, why aren't you using this, or why didn't you do that? Because we started in 2013, and we had a business. We had people to support, right? So being on the latest and greatest isn't always where you want to be, but we pay attention to it because Microsoft changes what works, how it works, and often if you want the good stuff, you need to move forward. Moving to ARM was one of the best things we did. It's able to allow us to support a lot of new features. And ultimately, there's no place like production. One of the things that we made the mistake at times is we would sit and write code too long before we gave it to customers. Or we would think of an idea before we let them try it. Build your MVPs, get it out to your customer, let them try that, take feedback. Don't take it personally. They're going to call your baby ugly, and you just have to get on with it and continue to move forward as you do things. Well, folks, I hope you enjoyed it. I hope you learned something. Email address, Twitter handle, blog. Thank you so much for coming to Tech Days and my talk. Enjoy the rest of your day and have a nice lunch. Thank you. Goodbye.